Hi everyone, my name is Ritam Sarmah. I'm a student working at UCLA HCI Research, and on behalf of my amazing collaborators from UCLA and Carnegie Mellon, I'm excited to present to you Geno, a developer tool for authoring multimodal interaction on existing web applications. So intelligent voice interfaces have exploded in popularity in the past few years, and products like Siri and Alexa have demonstrated that users appreciate certain advantages of the voice modality, namely the convenience and efficiency of just telling a computer what to do. Now, what happens if we consider voice input in the context of web apps? Well, we get a lot of additional benefits by enhancing accessibility for impaired users and the expressivity of the pre-existing mouse modality. Despite all that, we currently aren't seeing many voice-enabled web apps right now, and we asked why. Well, we think one of the major reasons is that implementing voice interfaces for web apps is challenging and time-consuming for developers. It requires writing new code and refactoring existing code. Many web developers don't have prior experience with natural language processing, which is often a complex, specialized area. And there's a lack of consistent methods for creating multimodal interfaces, specifically for combining voice seamlessly with a prior mouse-based user experience. Now, I want to actually motivate multimodal interfaces a bit more with an example. Say we're looking to buy new earbuds online. A multimodal approach would allow the user to point at the product image and say, "Deliver this to my office address." The mouse position plus the voice command give enough context to understand the user, so the combination of synergistic modalities optimizes the interaction by reducing task time. So what has prior work focused on in multimodal programming? Many have already investigated best practices and techniques for building interactions like the shopping example we saw, and our goal is to allow developers to apply these existing techniques in the context of web apps without worrying about the underlying details. There have also been many different tools to facilitate multimodal programming, from specification languages to prototyping tools. But oftentimes these tools have high learning curves that add to development time or don't integrate well into a prior code base. So we wanted to provide a simple, unified GUI-based workflow for working with different modalities. And further, we want to enable easy integration of our toolkit into existing web apps for enhancing accessibility. Which leads me to introduce Geno, a developer tool for adding voice input multimodally to existing web apps without requiring significant NLP expertise. I want to now describe the high-level architecture for Geno. If you're interested in more specific details about the implementation, please refer to our paper. So developers use the Geno IDE for creating their multimodal interactions. It's built using JavaScript and the Electron framework, allowing it to seamlessly interact with the developer's web app, as well as providing a cross-platform desktop app experience. The IDE trains a custom natural language model for the web app that understands voice commands, which we call utterances, associated with the developer's multimodal app interactions, which we call intents. This model is generated using the open source library Rasa on a remote backend, and is able to classify intents and extract important entities from utterances, which we'll understand more about in a bit. The IDE is also automatically generating code and configurations in the project as the developer is working. The developer just has to ensure that they import the Geno library in web pages with configured intents. At deployment, Geno includes a non-intrusive UI into the application for the end user to interact multimodally. We use the Web Speech API for speech recognition and communicate to the backend model via HTTP requests in order to determine the user's intent for deciding what action to trigger. Let's take a look at the end user's experience when using a Geno-enabled app like this calendar. In the bottom right, we see a voice UI overlay, which Geno automatically adds for speaking voice commands. To change the calendar to a different view, we could click on it and say, "Change calendar to week view." Now, if we want to move an event to a new date, it's as simple as hovering over the event and saying, "Move this to next Tuesday." And sure enough, the event gets moved to the next week. We'll next look at the developer's perspective and using Geno to build the interactions we just saw. The high-level workflow follows 3 steps: specifying a target action, configuring the voice input, and optionally adding multimodal context. First, here's a quick overview of the Geno IDE. From left to right, you can see a file explorer, code editor, and a browser app preview. Opening a project in Geno automatically generates all the necessary library files in the workspace to get the developer up and running. To create our first user interaction, or what we call an intent, we need to determine a target action to be triggered by the voice command. We can choose a pre-existing JavaScript function by just clicking on a circle next to it, or alternatively, we can choose a sequence of UI interactions by demonstrating them within the web preview. So to implement an intent that switches to the weak view, we can demonstrate clicking on the weak button to create a voice input mapped to that action. And when we're done, we see the same popover for configuring our voice input, which we'll look at how to do next. To configure our voice input, we first add a unique intent name, and then add example utterances that the end user can say to trigger the corresponding action. These examples are actually used as training data for a custom language model for the app. So an example utterance would be move birthday party to April 15th. Now if we have function parameters, like in the case of moving an event name and date, we can teach the model to extract parameter values from the utterances by labeling them in each example. So clicking on an example opens up a secondary view where we can label entities with the corresponding parameter name. In this example, birthday party is the event name, and April 15th is the new date. Once we're done labeling all the examples, we just train the model, and a fully functional voice interaction is now part of our web app. We can now make this intent multimodal, which would allow a user to select one or more HTML elements via hovering or dragging as input. The selected element or its attribute values can be then passed directly to the target function as some parameter. For this example, we want to allow the user to hover over an event to provide the event name. So we first select a target parameter from the dropdown, click the crosshairs, and demonstrate our multimodal interaction in the preview. Geno then extracts the HTML attributes which can be selected to be used as the parameter value. So in this case, we're extracting the inner text attribute, say lunch, and passing that as the event name. And any element hovered with the selector div.fc-title will be supported as context for this intent. To evaluate Geno, we used it to build multimodal interfaces for a number of pre-existing websites. A few scenarios we tested included searching for related news articles on New York Times, manipulating complex 3D models, and adding songs to a playlist in a music player. We also conducted a developer study with 5 computer science students and 3 professional engineers, totaling 8 participants. Our participants had a range of experience levels in web development, and only one of them had any prior experience with voice interface development. We gave our participants the code bases for a calendar and music player and asked them to implement 4 multimodal interactions in under an hour. For the calendar, that included moving an event and switching to weak view. And for the music player, they had to implement skipping to the next song and adding a song to the queue. Ultimately, 6 of the 8 participants successfully completed all 4 tasks in less than an hour, and only 2 of the novice participants completed a subset in the allotted time. This was mainly due to them being less familiar with JavaScript and spending more time writing and testing functions during the study. We also asked the participants to share their thoughts about Geno, and they overall found it easy to use, with one claiming Geno's learning curve is much better than that of a library. They also felt comfortable learning and applying NLU concepts despite limited prior experience, with one participant saying Geno made things a lot less complicated than they expected, and another saying Geno helps lower the barrier of entry for incorporating machine learning into your product. I do want to mention some current limitations with Geno. Right now, intents only map to a single target action, and multimodal context only supports configurations for one parameter. It's also dependent on HTML element attributes having sufficient context info. So if an element does not have enough information, then the developer might have to go back and add some information to support multimodal context. And so far, we've only tested on single-page desktop web apps. Our future work includes looking into supporting multi-page web apps and supporting multimodal context for, say, mobile touchscreen devices. To wrap things up, Geno enables voice input in existing web apps by building off of existing functions and UI elements. It abstracts away NLP and multimodal implementation details in its workflow, allowing web developers with little NLP experience to build useful multimodal interactions in a short period of time. If you're interested in more details and further discussion on our work, feel free to check out our paper, as well as our GitHub code, which is accessible through this link. Thank you.